Hello students, in this video we are going to learn about logarithm. Um, let us start. Now let us consider this exponential form a power b equal to c. Okay, now I'm going to write this in logarithmic form. Um, I'm not going to go into the history of logarithm or start from the basics. Basically, I'm going to just tell you about logarithm, laws of logarithm, and solve problems. In fact. Okay, so a power b equal to c. So let us take now this a is the base, this expression, and this b that you see here is the power or the exponent, and this c is the value. Okay, now when I convert this into logarithmic form, logarithm will also have a base and it will have the same base as this. So the base is a, so here also the base will be a. Now the power will become the value for the logarithm, so it will become equal to b. The power of this expression will become the value of logarithm, and the remaining expression is c, so log c to the base a equal to b. So I'll read it as log c to the base a equal to b. So let us see one more example. X power y equal to z. So I can write this as log, the base is x, so for log also the base will become x, the power is y, that will become the value, and whatever is left will come here. So log z to the base x equal to y, right? Okay, let us see one more example. 10 raised to minus 3 equal to 0.001. So how do I convert this into logarithmic form? How do I write it in logarithmic form? Very simple. The base is 10. So for logarithm also the base will be 10. The power is minus 3. So that will become the value minus 3. And whatever is left out will come here 0.001. So log 0.001 to the base 10 equal to minus 3. Okay, one more example. Let's say 5 power y equal to 1 minus x. Okay, so I've written it as log. The base is 5, so here also the base will be 5, and the power is y, that will become the value equal to y, and whatever is left out will come here 1 minus x. Okay, so converting an exponential form into logarithm form is very simple. The last example, 2 power 2 raised to 4 minus x equal to, let's say, 3. Okay, so I can write it as logarithm form. So log of the base will become the base here, and the power will become 4 minus x equal to the value here, and whatever is left. So log 3 to the base 2 equal to 4 minus x. Good. Now we saw how to convert an exponent form into a logarithmic form. Now we are going to see how to convert a logarithmic form into an exponential form. Okay, so let us see some examples. Log b to the base a equal to c. So how do I convert this into exponential form? Very simple. As you can see, the base of the logarithm is a. So for exponent also the base will be the same. So a, and the value of the logarithm will become the power. So a raised to c equal to, and whatever is left out will come here. A raised to c equal to b. One more example. Log x to the base y equal to z. So the base of the logarithm is y, so that will become the base of the exponent as well, y, and the value is z, that will become the exponent power z equal to x. Okay, and let's see one more example. Log y to the base 10 equal to 1 minus x, so which implies the base is 10, so base is 10, the value is 1 minus x, so that will become the power 10 power 1 minus x equal to, so whatever is left out will come here. Yeah, 10 power 1 minus x equal to y. It's very, very simple. So what I'm going to do now is I'm going to give you around 5 problems. So if it is in exponential form, you should convert it into logarithmic form, and if it is in logarithmic form, you should convert it into exponential form. So let us see how many of you get all 5 right. Okay, look at these problems, students. I have given you 6 expression, 3 in exponential form and 3 in logarithmic form. Now you are supposed to convert this into exponential to logarithmic form and logarithmic to exponential form. So start doing it. You can pause the video now and then write the answers, and once you're done you can check your answers. Okay, so let me write the answers. The first one is in exponential form, so I should write in logarithmic form, so it will become log 5 will become the base 125 equal to 3. So this is the first answer. The second one is 6 raised to 3 equal to 216. The third one is 4 raised to x equal to 81. The fourth one is log 90 to the base x equal to 4. Fifth one, the answer is log y raised to 5, y to the base 5 equal to x. And the last one is y power 10 equal to x squared plus 2. So I hope you got all of them right. Very good. So let's go to the next concept. Let's say what if I want to find log let's say 81 to the base 9. Let's say I want to find the value of log 81 to the base 9. How do we find it? So very simple. I'll take the value as x, so let it be x. Convert this into exponential form. So as you know, it will become 9 power x equal to 81. And check whether 81 can be written in terms of 9. Like in terms of 9 means as a power of 9. Let's say 9 power 1 or 9 power 2 like that. Yes, definitely I can write it as 9 power 2, isn't it? 81 is 9 squared. Now we know that if the bases are same, then the powers are also same. For example, if a power x equal to a power y implies that x equal to y always, only when a is not equal to 0, 1, 0 and 1, or even minus 1 also. Okay, so which means the bases are same, so the powers are also same. So x is 2. So what it means is log 81 to the base 9 equal to x, which is 2. So the value of log 81 to the base 9 is 2. Okay, let us see one more example. Let's say I want to find log of 1 by 27 to the base 3. I want to find the value of this expression. I'll take it as x. So convert this into exponential form. So 3 raised to x equal to 1 by 27. 1 by 27 can be written as 1 by... Now you can see here the base is 3. So please check whether you can write 27 in terms of 3. So I can write 27 as 3 power 3, which is nothing but 3 power minus 3. So the bases are same, so the powers are also same. So x equal to minus 3. So what it means is this value is minus 3. Okay, one more example. Log of root 3 to the base 3. I want to find the value of this. So I'll take it as x, convert this in exponential form. So 3 raised to x equal to root 3. Now I know that root 3 can be written as 3 raised to half. Again, the bases are same, so therefore the powers have to be same. So x equal to half. Very, very simple. Last problem of this type. Log of 0.0001 to the base 10. I want to find the, let's say, the value of this. So I'll take it as x. So I get 10 raised to x equal to 0.0001. Now I need to find out, since the base is 10, I should write this expression in terms of 10, let's say 10 power 4 or whatever it is. So this can be written as 1 by 10,000, isn't it, students? Because 0.0001 is 1 by 10,000, which is nothing but 1 by 10 power 4. So 10 power x equal to, now this 10 power minus 1 by 10 power minus 4 can be written as 10 power minus 4. Again, the bases are same, so the powers have to be same. So x is minus 4. So x here is minus 4. Very simple, right? Okay, I'm going to give you 5 problems, and you should find the values of each one of those logarithms. Okay, let us find it. Okay, so these are the problems, students. We can start solving them now. Log 125 to the base 5, log 1 by 16 base 2 to the base 2, log 32 to the base 2. Okay, so start solving it. You can pause the video, and after solving it, you can start playing it again. So let me write the answer for the first one. So log 125 to the base 5 equal to x. So I write it in exponential form. So 5 raised to x equal to 125. Now since the base is 5 here, I need to write 125 as a power of 5. I know that 125 can be written as 5 cube. So the bases are same. So the powers have to be same. So x equal to 3. So the answer for the first one is 3. Right? So let us look at the second one. Log 1 by 16 to the base 2. I want to find the value of this. I'll take it as x, convert this in exponential form. So 2 power x equal to 1 by 16. Now again, since the base is 2, you have to check whether you can write 16 as the power of 2. Yes, I can write 16 as 2 power 4. So I can write 1 by 2 power 4 as 2 power minus 4. The bases are same and the powers are also same. Therefore, so x equal to minus 4. So the answer for the second one is minus 4. Okay, let's start doing it. I hope, let me write the answer for this. So it can be written as 2 raised to 4 equal to x, which is nothing but 16 equal to x. So the value of x is 16. Very simple. So next problem. Log 3 to the base x equal to half. So please solve it on your own. You need to find the value of x here. Okay. Let me convert into exponential form. So it can be written as x raised to half equal to 3. Now we know that x raised to half is nothing but root x equal to 3. Again, we know that square root of 9 is 3, so x has to be 9. X definitely has to be 9. Okay, third sum, one more sum. Log of let's say 81 to the base 3 equal to x plus 1. Okay, so let us find the answer now. Convert this in exponential form. I write it as 3 power x plus 1 equal to 81. Let me check whether, since the base is 3, whether I can write 81 as the power of 3. I can write it as 3 power 4. So since the bases are same, the powers are also same. So x plus 1 equal to 4, which means x equal to 3. Okay, simple. One more problem. Log 2 to the base x equal to 4. I need to find the value of x. So I can write it as exponential form, x power 4 equal to 2, which means x equal to 2 raised to 1 by 4, isn't it? Like so, which is nothing but 4th root of 2. Yeah. Okay. I'm sorry. If x power 4 is 2, then what will happen is it will be plus or minus this, so I'll get plus or minus here. That's the answer. But we'll see later that the base that you see here can never take a negative value. It cannot be negative. We'll see later why it is so. So which means that x has to be plus 4th root of Okay, the minus 4th root of 2 is not possible. So you can even safely say that you need not write plus or minus, but fine. I'll explain later why it is so, why x cannot take the negative value. Okay, now let us see loss of logarithm. I'm sorry, I think before that I told you just now that why the base cannot be negative. So let us check that first, and after that we'll come to loss of logarithm. So let us consider this expression log a to the base b equal to c. Okay, so let us consider this. Now let me start with the b first, the base first. So I'd like to know what values can b take, or is there any value that b cannot take? Okay, now we all know that, like for example, this logarithmic can be written in exponential form, exponential, I mean both, for example here, b power c equal to a. So both these are equivalent expressions, isn't it? This is in logarithmic form and this is in exponential form. Okay. Now, when I write this as, let's say, log y to the base minus 2 equal to, let's say, some x. Okay. So this will become minus 2 raised to x equal to y. Okay. Now, this you see here is not an exponential function. For an exponential function, the base has to be positive. So therefore, this cannot be negative. Okay. In fact, in one of my videos where I teach you about functions, I will explain in detail as to why it cannot be negative. Why is that y equal to minus 2 raised to x cannot be a exponential function? But let me just give you, let's say, a simple example. Let's say log y minus 2 equal to, let's say, for example, half, right? So this means minus 2 per half equal to y. That means root of minus 2 equal to y. Now we all know that square root of minus 2 is not a real number. That means y is not a real number. Okay, so I don't know whether this is a simple example. So the base b cannot be negative. Okay, that is one important fact. Okay, so let me write it once more. Log a to the base b equal to c. So we know that b has to be positive. Okay. Now what about, let's say, can b take the value of 1? So let me check it. Log 5 to the base 1. Let's say I want to find this. I'll take it as x. Let's say I take it as x. So when I write it in exponential form, I'll get 1 raised to x equal to 5. Now we all know that whatever be the value of x, it can never take 5, isn't it? 1 power x equal to 5 is not possible at all. You cannot solve it. Okay. Same way, even if you replace 5 with, let's say, 6, if you replace 5 with 6, same thing. 1 power 6 can never be, 1 power x can never be 6. So basically what it means is b also cannot take the value of 1. So b has to be positive and b cannot take the value of 1. Okay. Okay. So we discussed about b. Now let us discuss about a. Okay, I want to discuss about a now. Now what about a again? Can a be negative? So let us see an example. Log minus 2 to the base 3. I want to find the value of this. I'll take it as x. So I can write this as 3 power x equal to minus 2. Now we all know that whatever be the value of x, 3 power x can never be negative, isn't it? For example, 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27, 3 power 4 is 81, and let's say 3 power, let's say 1.5 is a value between 3 and 9. So, but they're all positive. So it is not, you cannot get a negative answer. So what it means is this is not possible. Therefore, a again cannot be negative, so a has to be positive. Okay, the next question comes. Can a take the value of 1? Fine, let us check. Can a take the value of 1? So let's say I want to find log 1 to the base b. Okay, b is anything. Let's say b can be, as you know, b is positive number not equal to 1. I want to find whether this is possible. So let me take it as x. So b power x equal to 1. We know that when x is 0, b power 0 will definitely be 1, isn't it? B power 0 is 1. So x, yeah, x is actually 0. So same way, in fact b is a variable, isn't it? I can replace b with any number, like I can replace it with 5 or 4. Basically you'll always get 0 as the answer. So a can be 1, not an issue. So this is the only condition. Sorry, a has to be positive. Let us come to c finally now. Now you will notice that c can actually take any real number. So c belongs to R. That means c can be any real number. It can be positive, it can be negative, it can be 0 also. Just now we saw log 1 is 0, so it can be 0 also. So these are the three things you need to keep in mind. The base b should always be positive and it cannot be equal to 1. The a that you see here has to be positive. So what it means is you cannot find logarithmic of negative value. For example, you cannot find log of, let's say, minus 5 to the base 2. You cannot find it. And finally, c, the value of logarithm can be any real number. Okay, fine. I hope it is clear. Now let us go to laws of logarithm. Okay, the first law is called as product law. So I can write log of x into y to the base a can be written as log x to the base a plus log y to the base a. So this is the first law. In fact, it flows from a property that this, for example, we have this exponential property a power b into a power c equal to a power b plus c. Okay, this property of exponent, basically you get this from this, but I'm not going to explain how it is so. So this is the property. So basically, if you have it in product, you can write it as sum of two logarithms. Now you can extend it to any number of variables. For example, what I'm trying to say here is log of x into y into z to the base a can be written as log x to the base a plus log y to the base a plus log z to the base a. Okay, so let's say how can I write log let's say x square to the base a? I can write it as log of x into x to the base a. Again I can use the product law, so log x to the base a plus log x to the base a. Okay, using the product law, which basically means 2 times log x to the base a, right? So I hope this is clear. This is a very important law. Log x into y to the base a can be written as log x to the base a plus log 8 y to the base a. Now this can also be rewritten as, okay, you can also say like that, for example, log let's say a to the base b plus log c to the base b. So suppose you have two logarithm in addition and the bases are same, then I can write it as a product. So log a into c to the base b. It's the same as this. So basically sum of two logarithms can be written as a single logarithm provided the bases are same. Okay, so let us see some examples. Log x to the base 3 plus log 4x to the base 3. I can write it as a single logarithm. I can write it as log x into 4x to the base 3. So basically it means log of 4x squared to the base 3. I can write like this. So let us see one more example. Say log x squared to the base 3 plus log y to the base 3 plus log root z to the base 3. Then I can write it as you can see, all these logarithms, the bases are same and they are in addition. So I can write it as single log with multiplication, log x squared into y into root z to the base 3. Okay, so this is the product law. So let us solve some problems based on product law. Okay, let's say I want to find the value of x in this logarithmic equation. So log x to the base 2 plus log x plus 2 to the base 2 equal to 3. You can see the bases are same and it is in addition. So I can write it as a single logarithm. So I can write it as log x multiplied, log x multiplied with x plus 2. So I can multiply this and this, and to the base 2 equal to 3. So basically I get log x squared plus 2x to the base 2 equal to 3. Now I can convert this into an exponential form. So I get 2 raised to 3 equal to x squared plus 2x. So I'll get x squared plus 2x equal to 8, which means x squared plus 2x minus 8 equal to 0. Okay, so I can factorize it as x plus 4 into x minus 2 equal to 0. That means x is either minus 4 or x equal to 2. Okay, but can x take the value of minus 4, students? Now, for example, can x be minus 4? I said no, isn't it? For example, if x is minus 4, I'll get log minus 4 to the base 2, which is not possible, isn't it? I told you very clearly that this one cannot be negative. So therefore, x has to be 2. So for this problem, the solution is x equal to 2. Okay, let us learn the next law now, quotient law. Log x by y, so you have a quotient here to the base a, can be written as log x to the base a minus log y to the base a. So if it is in quotient, then it can be written as difference. If it is in product, it can be written as a sum. If it is in quotient, it can be written as the difference. So what it means is log, let's say x squared by y to the base 3. So I can write it as log x squared to the base 3 minus log y to the base 3. Or other way around also. For example, if it is log a to the base b minus log c to the base b. So if there are two logarithms with the same base in difference, then I can use quotient rule. I can write it as log a by c to the base b. So this is what the quotient rule says. So let us see some examples. For example, let's say log of 100x to the base 10 minus log of xy to the base 10. So you can see both the bases are same and it is in difference. So I can write this as log as a quotient 100x by xy to the base 10. So basically, which means that log of 100 over y to the base 10. Okay, so one more example. Now this time around we'll see a combination of, we'll use product as well as quotient rule. Okay, now look at this expression, students. Suppose, let's say you need to simplify. There are 3 logarithms. You need to write it in terms of a single logarithm. Now I've seen many students make the same mistake again and again. Let's see what mistake they make. They write like this: log x to the base a minus, and for this one they use the product law. That means you have 2 logarithms with the same base with the addition sign in between. So they write it as log of y z to the base a. Then, okay, now again both two logarithms with the same base, difference is there, so they write it as log of x divided by yz to the base a. This is how I write it. They write it, sorry, this is completely wrong. So what is wrong here? For example, it's like saying, for example, let's say you have 10 minus 3 plus 4. Okay, so we know that 10 minus 3 plus 4 is nothing but 11, isn't it? But it's like saying 10 minus, oh, 3 and 4 is there, so I'll write 10 minus 7, so which is 3, which is incorrect, isn't it? So what is the problem? What is the mistake that you did? Very simple. You took it as 3 plus 4, which is incorrect. So same way, let me erase this. What you need to do is, first you finish off this. First you finish off this. So that means I'll get log x by y to the base a plus log z to the base a. This is correct. Now I can use the product rule. So log x by y multiplied with z to the base a. So log of x z by y to the base a. So this is correct. But suppose, okay, suppose it is given like this. Suppose if it is given like this, then I hope you remember the BODMAS rule. You should finish off the bracket first. So this means log x to the base a minus log y z to the base a. That means I have used the product rule here. Now next I write log x divided by yz to the base a. Now this is absolutely correct. Okay. So but what if you have like this? Let's say you have log x to the base a minus log y to the base a minus log z to the base a. Now how do we do this problem? You can do it in two ways. I can write it as, I can take this first and use the quotient rule. So log x by y to the base a minus log z to the base a. I can write like this. Then I can write it again, I can use the quotient rule. So log x by y by z to the base a, which basically means log of x by yz to the base a, isn't it? So I can also write like this. Okay. Of course, there is another way of doing it. As I mentioned, there is another way of solving this. I can write it as log x to the base a minus 1 into, I can write it as, I can take minus 1 common, so log y to the base a plus log z to the base a. So which basically means log x to the base a minus, I can use the product rule here, log yz to the base a. Now I can use quotient rule here. So log of x over yz to the base a. Right? It's very, very simple. Then now you do this yourself. Log of 8x cubed to the base 2 minus log of x squared to the base 2 plus log of y over x to the base 2. Okay, you can pause this video and then solve it yourself. Okay, so let us solve it. So what I'll do is I will, as you can see, you cannot do this simply with the second and third term first. First do the first and second term. So I can use, for this one I can use the quotient rule. So log of 8x cubed by x squared to the base 2 plus log of y by x to the base 2. So I can write it as log of 8x to the base 2, because x cubed by x squared you cancel, plus log of y by x to the base 2. Now I can use the product rule. So two logarithms with the same base and addition in between, plus sign in between. So log of 8x into y by x to the base 2. So basically you will get log of 8y to the base 2 as the answer. Okay, let us solve this problem. I need to find the value of x here. As you can see, there are two logarithms. The bases are same. The bases are same, and there is a minus sign in between. So I can use the quotient rule. So I can write it as logarithm log of x plus 2 divided by x minus 1 to the base 10 equal to 1. Okay. Now I should convert it into exponential form. So exponential form is x plus 2 by x minus 1 equal to 10 power 1, which is 10. Now you can cross multiply, you get x plus 2 equal to 10x minus 10, which implies 9x equal to 12. So x is 12 over 9, which is nothing but 4 over 3. So for this problem, the answer is 4 over 3, 4 by 3, 1.33 approximately. Okay, now there is one important property. If log x to the base a equal to log y to the base a. Okay, so if the bases are same, then definitely x will be equal to y. Okay, don't say oh, I cancel this, that is incorrect. Don't cancel it, but just write. So when if log x to the base a equal to log y to the base a, this implies x equal to y. Please never write like this, like cancelling it. No, you don't cancel, you can't cancel it. Okay, so let us solve some problems using product rule as well as quotient rule. Okay, this is the first problem. Log of x plus 1 to the base 2 minus log x to the base 2 equal to log 3 to the base 2. So what I'll do is left hand side, I will make it into a single logarithm using, as you can see, the bases are same and there is a minus sign in between. So I can use the quotient rule. So I can write it as log of x plus 1 over x to the base 2 equal to log 3 to the base 2. Now just now we learned that if you have both sides logarithm, if the bases are same and both sides there's only one single logarithm, the bases are same, that means this and this will be same. So x plus 1 by x equal to 3, which implies x plus 1 equal to 3x. So you'll get x equal to half as the answer. Very simple, very simple problem. Let us see one more problem. Now, okay, this is the problem, students. Now I'll give you a hint as to how to solve. So what you do is you bring this to the left hand side. So log of x squared plus 1 to the base 10 minus log of x minus 2 to the base 10 equal to 1. Okay, now look at the left hand side and check whether you can use product rule or quotient rule to solve this problem. You can pause the video now. Okay, so let me do it. So as you can see, the bases are same and there is a minus in between, so I can use the quotient rule. So the quotient rule says that log of x squared plus 1 by x minus 2 to the base 10 equal to 1. Now what do? I have to convert this into exponential form. This means x squared plus 1 by x minus 2 equal to 10 power 1, which is 10. So let me cross multiply now. X squared plus 1 equal to 10 times x minus 2, which is nothing but 10x minus 20. So you'll get a quadratic equation, x squared minus 10x plus 21 equal to 0. So when you actually solve it, you'll get two answers. X is either 3 or 7. Now you need to check whether it is possible. Okay, let me take 3. Then I'll get, this will become 3 square plus 1 log 10, not a problem. This will become 3 minus 2, which is 1, again not a problem. Yeah, so now let me take 7 now. If you take 7 now, then 7 square plus 1 will be 50. So it's a positive number, not an issue. Again 7 minus 2 is 5, a positive number, so not an issue. So both of them are solutions. Okay, so I hope it is clear. Okay, let us look at this problem. Log of x minus 2 to the base 3 plus log of x minus 4 to the base 3 equal to 2. Now, as you can see, the bases are same and there is addition sign in between, so I can use the product rule. So I can write it as log of x minus 2 multiplied with x minus 4 to the base 3 equal to 2. Now I can write it write in exponential form. So I get x minus 2 into x minus 4 equal to 3 power 4. Now open the bracket here, so I get x squared minus 4x minus 2x plus 8 equal to 81. So I get x squared minus 6x plus 8 minus 81. So you'll get minus 73 equal to 0. Now obviously you cannot factorize it, so you use the graphic display calculator to find the solution. I'm sorry, I think I made a small mistake here. So it is not 3 power 4, it is basically 3 power 2, isn't it? Okay. So we have to be very careful. So it is 3 power 2. So basically what it means that this is 9. This is 9. So please be very careful while doing problems. So basically I will get x squared minus 6x minus 1 equal to 0. Again, anyhow, you have to use a graphic display calculator to find the values of x. And once you find the values of x, you please substitute them in here and make sure that they do not become negative, right? Okay, fine. Thanks for watching this video. So what I'll do is, this is the first part of the logarithm. I'll do one more video on logarithm where I'll cover the power rule and also the various other properties of logarithms. And of course, we will do quite a number of problems. So please stay tuned.